Okay, hi Oliver, it's me. So this is your question today. We were talking today about this question number 31 on page 812. Okay. And we were talking about the fact that at point P, we know that F sub x is positive. Okay. Because if we have point P, oh my goodness, being very loud. If I have point P and if I head in this direction, right? If I head in this direction, um, given the values of z, if I head in this direction, my z values are going to increase. And your point was, if I look at this trend, the trend being this way, right? The nature of f sub x. Your question was like, how do we know this distance isn't so small that it kind of overrides the change in z? And so I guess here's a partial answer to this question. And if this doesn't answer all of it, we can continue talking tomorrow. But I want to make sure that I certainly didn't want you to feel like I was neglecting your question or leaving you out. So here's a part of the answer to the question. In any given problem, the distance here between contour plots is assumed to be relative within the problem. So in other words, if this distance here is, say, a distance of, oh, I don't know, 1 meter, then it is assumed by scale that this distance here is like 1/10 of a meter. Okay. So within any problem, the scale is assumed to be held constant within a question. So in other words, you would never have a case where, for example, this distance here was, 5, and this distance here was 0.01. Why? Because if you look, like this distance is not 1/100th of this distance, okay? So relatively speaking, we take these distances to be relatively constant. And of course, my drawing here of 31 is not perfect, but you could look at your book for kind of what I'm trying to convey. The other thing we talked about today was, if I look at this point P, and if I look at the way P is changing, if I move up in the direction of increasing Y, and look at P here, okay? So, accordingly, this looks like if Z is 5 here and Z is 3, maybe Z is 4 as you pass through P, right? And maybe Z is 1 here, okay? So Z is equal to 1. What I'm saying is, if you look at some horizontal distance that's constant, so let's take a look at this, all right? Let's look at this distance horizontally. And I'll take that same distance here horizontally in the x direction, that means, okay? So what happens is, here's my new point P. Here's my new point P here, okay? So again, I'm going to be a little bit rough with my estimating, but I can say that, let's say, P went from 4 to 5, but P here went from 1 to, oh gosh. Okay, you know what? Oh, here's where my drawing is just awful. Okay, let me try and redraw it, Oliver. Hang on a second. But what I'm going to do? Actually, let's do this. Okay, look with me on your book. I wish I could take a picture of your book, but look with me on your book, okay? Do you see at P, that value of P in the book, P equals 4, right? Okay, what I want you to do, all right, hang on. Okay, I redrew this, all right? So here's what I want you to look at. Let's take a look at this. Let's just compare this P, which in number 31 is sitting on it looks like, I don't know, let's just say it's 2, right? It's sitting on this curve when Z equals 2, right? I know the 1, 3, and 5 in black are given in the book. Let's just do this. Okay, so at P is sitting on the contour plot for when Z equals 2, all right? And I want you to compare that with this point P right above on Z equals 1, all right? And let's do this. You ready? Let's move a certain distance, and the graph paper is going to help me. Let's go like this. Let's move 2 units over, okay? So I'm trying to be, let's see. Okay, I'm going to go this distance, right? So over this distance, the z value went from 2 to 3, okay? Over the same distance, Oliver, look at the blue point, that same horizontal distance, okay? Look what happened. Here, on this one, the change in z was approximately 1. I went from z equals 2 to z equals 3. But here, from this point in blue, over that same change, the z went from 1 to, let's say, 2.25. The change in z here was 2.25. So as I can see, that relative, the change in z as a function of x, which we're looking at this way, right? That change in z as a function of x increases as I look in the y direction. In fact, come on down with me here to this point. Let's put a point right here, right below p on this value of p. Let's make it, I don't know, what is this? 3, it goes 3 and then there's 1 below. Okay, here, take a look at this point p, right? And so if this is 3 and if this is 5, maybe this is, I can't say it's exactly 4, right? Because it looks like it's, well, let's see, from 1 to 3. So 1 to 3 is this distance, 3 to 5 is this distance, and maybe this is about just under 4. Like this looks like to be about 3.75. My point is, if I look at this, right, look at this change in z over, again, over that same distance, right? So these are all the same change in the x direction. Let's say it's just 1. But you'll see here, if this was about 3.75, I'm at this value of z, which is not even 5, because that would be going all the way over here. So as I look at the change in z as a function of x, this way, this way, this way, as I move in the y direction, which is looking at this way versus this way versus this way versus this way, the change in z is increasing. I actually think the red and blue point comparison is a little bit better, okay? But your question initially was like, how do you know this distance here isn't like 0.0001? And I think I answered that even in the first one with my bad drawing. Within any given problem, you take these distances to be relatively constant, okay? Which means this distance stands for the same quantitative change in z as this distance does if you take in their relative differences. Does that make sense? Okay. So anyway, Oliver, I hope that helped. And if not, we'll talk more tomorrow. But I think, your question was a really, really good one. And I guess the quick way to answer it is, within any question, you can assume relative constants. And I hope that helped. But you know what? Why don't you do number 30 and I'll do it with you. Good. Try number 30 and then replay me. And in the meantime, I'm going to try and draw the picture. Okay? Okay. Okay. Hello. So take a look at this one. This is question number 30, which looks a lot like question... Oh, sorry. Wait, did I do this right? Yeah, this is 30, which looks a lot like 31, but it's not. Okay, so let's see. Ready? So this point P is on this curve between z equals 5 and z equals 3. And if I'm looking at this, the trend kind of suggests that, z equals 1, z equals 2, z equals 3, z equals 4, okay? So I'm just going to put that in here because that's kind of what it looks like, right? And so if I look at this, let's take a look and see. If I travel this distance, okay, so I tried to go exactly 1 unit, 2 units, and again, my graph paper helps, versus, let's come right down to this one. Let's say I go, take a look at this point. Let's move point P down here. Here's point P, another point P, and I travel that same distance, okay? So if I look at this point P, it brings me from 4 to, what is this? Some number between 2 and 3, right? So from z equals 4 to some number between 2 and 3. Let's just call it 2.75 for kicks. So here, delta z, the change in z is negative, let's see, from 4 to 2 points, negative 1.25, right? But look at this same distance, this green point P, z equals 2 to z equals, well, let's see. If you look at this, right, if z equals 1 is down here, for me to get from an elevation or a z value of 2 to a z value of 1, I have to travel this far, all the way over here, which is certainly farther than, right, than this. And if I look at this, change in z, oh no, change in z here, it's negative 1.25. And then here it looks like the change in z is about, what is it, like negative, I don't know, what's delta z approximately? Negative like 0.25, okay? And look at the comparison, negative 0.25 to negative 0.125. Let's go up one. Let's see, does it go higher? It does. Okay, so I'm going to add the rest of these contour plots, but they get closer together. Oh no. Well, my artistic abilities are going to fail me. Let's put a point P right here on the 5, right? And let's travel the same distance. So z equals 5 here at that, and then I'll move this way. Boop. Right? Same distance. Now I'm right. Now I'm right here. Wait a minute. On this, travel the, okay, I'm right. Oh, look at that. I'm right about here, it looks like. And here it looks like the z drops from z equals 5 to z equals 3. Oh my goodness, negative 2. So do you see how delta z is decreasing? So in this case, for number 30, f sub xy would be negative because the change in z as a function of x is decreasing as I head in the positive y direction. In other words, the way z is changing, if I compare green first to red change in z to blue change in z, right? Those change in z's, those numbers are decreasing. Negative 1/4, negative 1 1/4, and negative 2. Okay? I hope that helped, Oliver. And if it didn't, we will talk tomorrow. If there is a 2-hour delay, I will see you like around 9:30, right? Okay, so I hope that helped. And I have to say, Oliver, now every time I think Oliver, I always think eyebrow. Because remember the day I almost called you eyebrow because your eyebrows are going up and down in a really fantastic fashion? All right, I'll see you tomorrow either at 7:40-ish or 9:40-ish or whenever you get there. And if we run out of time, we can always find additional time. And besides, I'm sure Spencer, your buddy, would love to join you anyway. Okay. Goodbye.